In this set of video notes, we're going to talk about Pascal's triangle and binomial expansion. So on the right-hand side, we have something called Pascal's triangle, which they found was a pattern. So Pascal said if I take 1 and I split it here, and I make 1 and 1, and then I go down here and I make 1 and 1, and then if I add 1 and 1, I get 2. And then again, I expand out, so I have 1 on the right, or 1 on the left, 1 on the right. And then if I add 1 and 2, I get 3, and if I add 2 and 1, I get 3. And then if I move down one more level, I expand out the 1 and the 1, and then I add 1 and 3 and I get 4, and 3 and 3 I get 6, and 3 and 1 I get 4. And then if I expand out one more, I have 1 and 1. And then if I add 1 and 4, I get 5, 4 and 6, I get 10, 6 and 4, I get 10, and 4 and 1, I get 5. We're going to use this concept when we expand something that is cubed, or to the 4th, or to the 5th, and make our life easier, rather than having to multiply each binomial times the other binomial, and then the result of that times the other binomial, and just keep going on and on and on. It'll take us forever. So what we're going to do is take a shortcut. So if you notice, all of the leading terms have a coefficient of 1, and they go from, this is really x to the 0 power, and it splits out. And if we look at all of the last terms, we notice that their exponent, or their coefficient, is 1 as well. So we have something like the triangle. And then if we look in the middle, in row 1, we have 1 and 1, right? And there's nothing in between. In row 2, notice I have a 2 here in the middle. And then in row 3, I have a 3a squared b and a 3a squared b, which is like my 3 and 3 on the right. And then I have my 4, 6, 4, which on this side we had 4, 6, 4. And then I have 5, 10, 10, 5. Over here I have 5, 10, 10, 5. So we can just keep expanding that out depending on what our exponent is. And so if we look here, we have to the 0, we just get 1. If we get to the first, we just get a and b. If it's to the second, the third, the fourth, the fifth power, then it's based on the row of Pascal. Let's go ahead and use that in our next slide. We have some information about binomial expansion here in this box. What we're going to look at specifically, we're going to look at the coefficients in the nth row of Pascal. We're going to look at the exponents that decrease for a, or start with the first term with the highest exponent and decrease, and b is going to start at 0 and increase as we go. So if we look at the example down here, we're going to start off, let's just kind of make our own Pascal. So at row 0, we're going to have 1, and at row 1, we're going to have 1, 1. In row 2, we're going to have 1, and then 1 and 1 is 2, and then 1. And at row 3, we're going to have 1, 2 and 1 is 3, 2 and 1 is 3, and 1 comes down. And let's just make row 4 just for fun. We have 1, and then we have 3 and 1 is 4, 3 and 3 is 6, 3 and 1 is 4. Come down, it's 1, and then let's make a fifth row. So fifth is 1, 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and 1. And then we're going to use this as we move down into our expansion. So going by what Pascal and our binomial expansions say, we are going to take the exponent 3. So this is cubed. So we're going to look at the third row of Pascal. And we're going to start writing. So we have k is our a. So we're going to start off with k cubed. And then we're going to make k squared. And then k to the first. And then k to the 0. So it goes down 3, 2, 1, 0. And then we're going to take a negative 5, which is our b. And we're going to multiply by negative 5 starting at the 0 power, and then times negative 5 to the first, times negative 5 to the second, and times negative 5 to the third. And then we're going to look at Pascal's triangle. So we're in the third row, so our exponents are going to be 1, and then we have plus 3 times k plus 3 times k again, and then plus 1. So let's simplify that out. 1 times k cubed times negative 5 to the 0, negative 5 to the 0 is 1, so this is just k cubed. Negative 5 to the 1 is negative 5, times 3 is negative 15 k squared. And then 3 times negative 5 squared is 25, times 3 is, 75k. And then negative 5 cubed is negative 125, times 1 is minus 125 k to the 0, right? Oops. But k to the 0 is really just 1. So we can rewrite it like this. In example B, we have cubed again. So we're going to start off with 6m. So we start with 6m to the third, and then we have 6m to the second, and then we have 6m to the first, and then 6m to the 0. And then we go increasing powers of b, which is negative 8, so we say negative 8 to the 0, negative 8 to the first, negative 8 to the second, negative 8 to the third. Then we're going to fill in Pascal's triangle. So we know this is cubed, so we're going to go to that third row again, and we have 1, 3, 3, 1. So we have 1 plus 3 plus 3 plus 1. And then we'll simplify. So negative 8 to the 0 is 1, and 6 times 6 times 6, we have 216m cubed. And then we have negative 8 to the first, and that's times 6 squared. So 6 squared is 36 times negative 8 times 3. So we have negative 864m squared. And then we have negative 8 squared, which is positive 64, times 3 times 3. So we have 1152m. And negative 8 cubed times 6 to the 0 power times 1. So we have negative 512. So in C, we have cubed. So we're going to start out with x cubed, then x squared, then x to the first, then x to the 0. And then we're going to go reverse. So then 2 is to the 0, then it's to the 1, then it's to the 2, then it's to the 3. And then we're going to plug in Pascal. So we know that in the third row, we know it starts off as 1, 3, 3, 1. And then we can rewrite it. 2 to the 0 is 1, so we just have x cubed. 2 to the first is 2 times 3 is 6x squared. 2 squared is 4 times 3 is 12x. And then 2 to the third is 8 times 1 is 8x to the 0. But x to the 0 is really 1. So we're done with that one. In the next example, we have the fifth power. So I'm going to start this down here a little bit so we can have some room. So we start off with x to the fifth, x to the fourth, x to the third, x to the second, x to the first, and x to the 0. And then we're going to go reverse order, negative 4, so negative 4 to the 0, negative 4 to the first, negative 4 to the second, negative 4 to the third, negative 4 to the fourth, and negative 4 to the fifth. And then we're going to put in Pascal, so let's go back up here for a second. So we're in the fifth row, so we have 1, 5, 10, 10, 5, 1. So let's go back down here, and let's insert 1, 5, 10, 10, 5, 1. And then simplify. So negative 4 to the 0, so this is just x to the fifth. Negative 4 to the first is negative 4 times 5 is negative 20 x to the fourth. And then we have negative 4 squared is 16 times 10 is 160 x cubed. And then negative 4 cubed times 10, and negative 640x squared. And then negative 4 to the 4th power times 5. So we have 1280x. And then negative 4 to the 5th power times 1. So we have negative 1024. And then remember that it's x to the 0, so the x goes away and we just have a constant. In our next example, E, I'm going to start off with 3x, and we have to the 4th power. So 3x to the 4th, 3x to the 3rd, 3x to the 2nd, 3x to the 1st, and 3x to the 0. And then we're going to go reverse. So we have 1 to the 0, 1 to the 1st, 1 to the 2nd, 1 to the 3rd, and 1 to the 4th. And then we're going to plug in Pascal's. So let's go back up and look at the 4th row. We have 1, 4, 6, 4, 1. So let's insert that. So we have 1 plus 4 plus 6 plus 4 plus 1. And then if we do the multiplication, we have 3 to the 4th, which is 81. So we have 81x to the 4th times 1 to the 0, which is 1. And then we have 3 cubed, so 27 times 4. We have 108x cubed. And then we have 3 squared, which is 9, times 6 is 54. And then we have 3 to the 1st, which is 3 times 4 is 12x. And then we have 3x to the 0, which is 1, times 1 to the 4th, which is 1, times 1 is 1, plus 1. And that's how you can use the binomial expansion using Pascal's in order to make, if we have a binomial to a power, easier to figure out.